Hello students, here is the second problem related to the thermodynamics. So the question is, the heat liberated on complete combustion of 7.8 grams benzene is 327 kilojoules. This heat has been measured at a constant volume at 27 degrees centigrade, and calculate the heat of combustion of benzene at constant pressure. This is the question. So we have to calculate the heat of combustion of benzene at a constant pressure. So let us see the concerned chemical reaction. So here it is, what they are given: the heat liberated on complete combustion of benzene. So benzene, C6H6, combustion means it takes up oxygens, gives rise to, releases carbon dioxide and water molecules. So by balancing this equation, we'll get almost 7.5 O2, 6 CO2 and 3 H2. So this is liquid, this is gaseous substance, and this is also gas, and this is liquid. So this is the constant chemical reaction to this problem. Okay, here we have heat liberated on complete combustion of benzene. Heat liberated on complete combustion of, how many grams of benzene they have given? 7.8 grams of benzene is equal to how much? 327 kilojoules. Okay, so for 7.8 grams of benzene, the heat liberation should be 327 kilojoules. For 78 grams of benzene, that should be 3270 kilojoules. Okay, you just do cross multiplication as well. 7.8 grams of benzene liberates 327 kilojoules. 78 grams of benzene, how much? You just do the cross multiplication. 327 into 78 by 7.8, that will give 3270 kilojoules. So at constant volume, the heat liberated is equal to delta E is equal to 3270 kilojoules. So here it is, the heat was liberated, that is nothing but an exothermic reaction. So that we should indicate the negative sign in this. Okay, so we know that the delta N value from the above equation. So what is delta N value? That is nothing but the moles of gaseous substances of product minus the moles of gaseous substance from the reactant. 7 1 by 2. 7 1 by 2 should be take it as 7.5. That is minus 1.5. Here R is equal to the universal gas constant, that should be 8.3 into 10 power minus 3 kilojoules Kelvin inverse, and the absolute temperature is given by 27 degrees centigrade, that should be added by 273, that will give us 300 Kelvin temperature. Okay, then we have to calculate the heat of combustion of benzene at constant pressure. So at constant pressure, we'll have an enthalpy equation. Delta H is equal to delta E plus delta N RT. So by substituting the values from this, minus in the place of delta E we have 3270 kilojoules, 3270, plus delta N value is minus 1.5 into R value 8.3 into 10 power minus 3 into T value is 300. So by solving this entire, we'll get the answer minus 3273.735 kilojoules per mole. Are you understood? If you have any doubts, you just comment me. Okay, bye.